All right, hello and welcome to the stream. Today is Friday. We're finishing off our second week of online AP Physics. All right. Today's going to be a very light day. Yeah. We're going to go over our quiz and then first talk about a few things. And that'll be pretty much it. We're finishing off our last unit. We're at the finish line. Might as well cross it, right? Uh, so you've been running this whole marathon. You're right there, and instead of going through the ribbon, you just jump off into the stands. I don't know. That doesn't seem right. So let's go and finish the whole race, cross the finish line, and then our focus will shift starting Wednesday. So here's some updates, some plans. Of course, we'll review the topics from our quiz. Monday, I'll go over the tippers and whatnot that we have that needs to be in our three-ring binder. I'm hoping that we can turn that in eventually for Q4. Tuesday, we'll play our Kahoot game for the entirety of Unit 8. And then on Wednesday of next week, we'll take another quiz, which will be slightly longer, and so worth some more points than what was yesterday. All right, and then starting from Wednesday, which is April 1st. Ooh, April Fool's Day. So I'll have to throw some banana peels on that quiz on Wednesday. So be prepared. What is the next quiz going to be on? All of Unit 8. So Wednesday quiz will be all of Unit 8. Okay. Now, and then Thursday is kind of a day before our break. Thursday, I would set into motion all of the things that we're going to review, and we have to shift our focus. I have all the information that I need from the College Board. They had me take a survey and all this other stuff today. This year it's going to be very simple, really. I know it seems doom and gloom, but there's some good out of it, right? So I'm sure you know a few things in that. The AP test is going to be online. It's going to be personal, so you'll be taking it in your personal device. They'll even allow you to take it on iPads and stuff like that. It is only 45 minutes, which is awesome, 45 minutes, and it's only FRQ questions, no multiple choice on the AP test this year. We'll be see again for next week. No, it'll be similar. Remember, some of you had some fill-ins, right? So we'll do some fill-ins too. So similar but longer. All right. So 45 minutes FRQ only this year, and they're still figuring out what days to give the test. They said you might be able to choose from 2 different days to take it, and they're basically taking surveys right now of what we feel should be the correct time frame. So I said that we should take our AP tests, between what was it, 11 through 15 or 18 through 22. Anything after May 22nd is kind of has diminishing returns, and that it might be slightly longer, but I know a lot of us have a exponentially decaying aptitude as summer approaches. As t increases, 1 over t squared gives you the times your efficiency rate, meaning it drops off as summer approaches very rapidly. So I suggested 11 through the 22nd as our time frame. But we'll see what the College Board decides. I'm sure they're taking all the stats from various teachers and stuff right now. And so yeah, it's 45 minutes, only FRQ questions. I'm guessing that if it were physics questions, it would be probably like 3 big questions, 3 big FRQ questions. Typically in our AP Physics C test, we have 3 FRQ questions anyway, and so each of them are like 15 minutes long. And I'm guessing that AP1 will follow the same thing because they're trying to crunch questions into 45 minutes. So at most it'll be 3. So basically, starting from Wednesday, we're going to start to predict what's going to be on the test, so you're well prepared. I want 100% fives this year. Let's go. Let's get it. 100% five rate. With only, with only 45-minute tests, this is going to be as easy as it can be, right? And of course, our focus will shift. Once we finish this quiz on Wednesday with Unit 8, our focus will shift to Units 1 through 7.5. Remember, we use a slightly different numbering system than the College Board does. The College Board has like 10 units separated. I've combined some of mine. So if you follow our 3-ring binders, it is 1 through 7.5. In that 7.5, remember, is the waves unit, but we don't actually talk about sound or anything on the AP test this year. It's everything up to shim. Everything up to shim. Easy peasy, lemon squeezy. All 5 gang. Yeah, I want as many stars on my wall as possible. Now, I have to change it up a little bit just so it's fair to all those who have come before you, right? You have to get a 5 in both my test and the AP test to get your star this year. And that goes the same to our APC students this year as well. You have to get a 5 in both the AP test and my test. Anyway, so that's the AP test. That's our plan. Any questions on what we're going to do in the next couple of days? So today, review. Monday, go over tippers and AP review and fix our binders so they're ready to go. I want to make the binders worth 100 points, so it will double up from Q3 and Q4. It'll count all together. That way it'll balance out our test category. And so we want to make sure that our binders are in pristine condition. And yeah. So, and then Tuesday, Kahoot. Wednesday is your big quiz. All right. So let us begin. If you're a stats person, here's some stats for you. Let's see. Let me pull it up. Ooh, where is it? Here it is. We did okay, I guess. Here's our stats. 68% average. Someone did get 100%. So yeah. Average time 15 minutes. Okay, not bad. But those are our stats. There we are. Let's talk about that question. It's pretty much the same question, really. I'm not going to harp on all the stats for this quiz, as it could mean many things because this is our first time taking an online quiz. So let's go and draw the circuit, right? It had two light bulbs in parallel with each other, and then one in series with that system, and then connected to a battery. Basically, the circuit was given to you later on. You just didn't initially see it. So the hope is that you actually draw the circuit out on your own, based on the information that's given. We have 2 in parallel and then 1 in series, and technically it doesn't matter which one is first and which one is second. Whether the parallel branches are first or whether the series one is first does not really matter, as everything gets the current pretty much at the same time. Oops, I forgot the third one. So it could be this way, or you could draw it like the circuit that was given in the 3rd or 4th question. I can't remember which one, but it could be something like this. Okay, no matter which way you draw it, whether A is first or A is last, does not matter. But we do know that B and C are parallel to each other. All right. And the first question was, which one is the brightest? Was that right? No. What was the first question? It gives you, it gave you some numbers, and it says calculate the current in bulb A in amps. Okay, that should have been an easy peasy question. If you do your current flow diagram, follow the process. We want to visualize the current as it's coming out of the battery. It goes this way. All of it goes through resistor A, or sorry, light bulb A, and then we hit this junction. Once we hit the junction, we'll split off between B and C. Some of it goes through B, some of it goes through C, and then it'll recombine again and go back into the battery. So that's our current flow diagram. And based on this diagram, we can say that I total, the total current that comes out of the battery, must equal the current that goes through bulb A, IA. Okay, so the next step is to just combine things, find rec, and then find the total current, and that should be it, right? So rec, if we use our notation from before, a couple days ago, 2 days ago was it, we see that it is RA plus the parallel of B and C. Okay, and if we have 2 in parallel, we can use rec for 2, product over sum. So we have RA plus RB, RC over B plus C. Ooh, that's not right. There we go. RC. And once you find rec, then you just do I total is equal to the total voltage, whatever's given, divided by the total resistance. Okay. Now, even though you're doing these problems, I want to make sure that you can visualize these in real life as well, because you're not going to build things with certain elements. So what does this circuit look like in real life? Let's see. First of all, I would need some sort of battery pack or something. Okay. In real life, is this real life? Is this real life? Does that mean before you guys? I don't know. Maybe you're too young for that meme. The is this real life meme. Here's my first battery. Now inside a battery pack, you would squeeze a battery in, and typically there's this spring on one end. Oh no, let me try that again. Typically there's this spring here. There we go. And you squish that spring in to put your battery in there. Okay. You want your flat side. It's too far to the left. There. You want the flat side to hit the spring part. This is just fake. It is. It feels like it. This isn't real physics. It's unfortunate that we have to do this. I mean, online distance education works for a lot of classes, really. Some classes where you have to read or do your own experimentation or research, and you write papers and all those types of classes. That works. It's just, physics, you really need to experience it. I hope that once we get back to school, I don't know if you heard, it's in May now, it's been extended. So we're still going to have our spring break, but that means we're going to run our spring break program, which is in your AP review section on the website. Go and do those practice exams that I talked about before leaving school. But after the spring break, we would just review for the AP test. And then whenever we come back, after the College Board decides when the AP test is, I will decide when my final is. So anyway. Here's more. Oh, this battery does not look right. Oh well. Alright, so what's special about a battery pack? Well, number one of the battery is right side up while the other is upside down. Why do they look different size? Let's try. Try to make them similar size. There we go. Alright, one is right side up, one's upside down. A lot of older remotes had this set up. Perhaps your video game controllers might have this set up. I suppose the newer, skinnier, thin remotes have like a vertical setup. Ooh, this is not good. So if you had a really thin remote, it would be like this. But in any case, a normal traditional battery pack has a little metal plate that connects one side of the battery to the other. So this purple thing is conductive metal, or a conductor. Okay, so now you have two wires that come out the same way. Whoa. Okay, this is the positive end and this is the negative end. That's because the positive end is eventually connected via this conductor piece and then back into the other battery. Okay. So let's go and take this route and then connect it into a port. The light bulb ports typically have two little connectors, little screws that you can screw onto. It has a little socket for the light bulb where you can screw the light bulb in, and voila, it's a light. What is this? Well, this connector eventually connects to the light bulb, goes through the resistor part, and then comes out the other end. Okay. Okay, let's quickly draw the other two. Here's our port, socket, light bulb, squiggly, and squiggly, and ta-da, we have light. Oh, not yet. Now we have a light. Yay! Okay, so here's our circuit. Alright. So anyway, we finished the first one. The second question asks, what does it ask? Blah, blah, blah. Calculate the bulb in amps. Which bulb is the brightest? Which bulb is the brightest? This is where you go to your power equations. Just find P1, P2, and P3. Or instead of using I1 V1, you would use I would use I squared R. Because we know all the R values, and as soon as I figure out the current, we can figure out what the power is, right? We know that I1 is the total current, and then here we have a split. So use the current splitter rule to find the other two currents. The current in B, bulb B, must be equal to the resistor in C divided by the resistor in B plus C times the total that comes in. That's the current splitter rule. And if you wanted to do C, C would be the opposite resistor, which is B, divided by B plus C times I total. Okay, so if you just split the current, or just, look at it conceptually, one of the resistors is twice as bigger than the other, so it's going to be a 2/3, 1/3 split. And once you recognize that, you could have just did fractional separation instead of doing the current splitter rule. Couldn't you do I tot minus IB for IC? Yes, of course, using the junction rule. That's Kirchhoff's junction rule. So IC must be equal to I total minus IB. Yeah, so you could have done that too. But in any case, look for patterns. So if you see that one's like twice as bigger than the other, like twice the resistance of the other, then you know it's going to be like a 1/3, 2/3 split. Meaning the smaller one will get 2/3 of the current, the bigger one will get 1/3 of the current. Okay, so by having this one in the front, because it gets all of the current at the start, or at the start of the circuit diagram, I squared R is going to give it a very high value, whereas the other two bulbs get partial, pieces of the current, and since current is squared in our power formula, the impact that you get from current is far greater than the any other values. Right? Everything else will be in proportion to this I value, this current value. So since we get all of it for bulb A, then bulb A is the brightest. And you can also, of course, use the numbers to figure that out. Okay. All right. Now, what about in the parallel situation? Okay. In the parallel situation, yeah, they might get different currents, and their resistance are different. We can use values and see. What is the next question? The next question is, if the circuit is modified so that it has a switch and you turned it off, all right, so now there's this switch here. We're going to put a switch right here between B and C. B and C. And if you take this switch off, pull it off, that means no current can go through and get to bulb C. Now you've reduced your circuit so that it's just the battery, bulb A, bulb B, and nothing else. Now it's just a series circuit. The other branch is turned off because there's no closed loop for the other branch. Okay, so all the current goes through A and all the current goes through B because there's only one path, and then we go back into the battery. My thing says you're offline. Yeah, hit refresh or something. F5. Okay. So since we only have one pathway, now I total, the new I total I should say, I total new is equal to IA is equal to IB. What is this new I total? Well, it must be the voltage divided by the new rec. We'll call it rec 2. I should have called it I total 2 or something, or prime. We like prime. Same V. So the rec here is now just the sum of A plus B. Right? What happened to this current? Did it increase or decrease? Chat, without doing the math, the fact that you took out bulb C, did you increase the resistance or did you decrease the resistance? Let's do a poll. You guys know what polls are here? I have a cloud bot, so with cloud bot I can do polls on stream if it loads. Poll. Alright, so here are the options for the poll. Rec new. So you would do exclamation point increase for increase, or sorry, exclamation point vote and then increase. Actually, that's too hard. Exclamation point 1, vote 1 for increase, and then vote 2 for decrease. Done. There we go. So you type exclamation point vote 1 or 2. Ah. Yeah, I want to do more of these. Yeah. Well, look at all these 2s coming in. Yeah. No, it's not exclamation 2. It's exclamation vote space 2. So there's a space here. So that's how you do votes. Yep. And so I can show you what that looks like on my screen. Let's see. Polls. Boom. This is what it looks like on my screen. Nope, never mind. Oh, there it is. Whoa, look at all these twos. Yeah. All right, I'm closing the poll. Thank you for participating. Yes, when you close off a branch, now less cars can flow through. So that means there are less. Oh, we got 100. Can we get 100 in the chat? So of course you're increasing the resistance. And so by increasing the resistance, you are decreasing the amount of current. Hundo, yeah. Shundo. Rest in peace, Pokemon Go. Can't play anymore. Oh. So yeah. So now the total current in the system, of course, is less. That means A is now getting less current than it was before. Okay. However, B no longer has to share its current with C, because all of it now goes through B. You need to spoof Mr. Z. Oh, no, I don't want to. I don't want to be a spoofer. That just ruins the game. Like some people in our class, I don't want to mention any names. Don't want to call anyone out. But you know, we're a real Pokemon master. You know, we want to travel the world to be the very best, like no one ever was. Whoa! Hey there, Bubble Guy! Don't call people out. Who knows? You know, Niantic might be watching, and then they'll take names and ban them. Report Slazer to Niantic. All right. So anyway, back to our circuit. We took out C. This increases the total resistance. This increases the total resistance, which decreases the total current. That means A gets less current, but B gets more current because there's no other pathway to share that current with. Therefore, it's getting more current than before. The increase in the brightness in B increases, while the brightness in A decreases. Okay, what happens to C? Well, C is dead, so no. Therefore, it's definitely decreasing. It used to be lit, but now it's not. Through Google Maps, yeah. All right. Was that it? Oh, there's this unit question. What was the unit question? What is kilograms, meters cubed over seconds, coulomb squared? Oh my god. This was nasty. This was definitely nasty. Now, the goal here is to recognize certain units in combination. When you see kilograms and meters and seconds, you should think about, like, I don't know, either momentum or forces. Start with forces first, because momentum isn't really used with other units, whereas force is. Like, for example, force times distance gives you energy. So that's the key. What you want to do with this is to split the unit up. If you have meters cubed, yes, that looks like volume, but if you think about forces, force is a Newton, which is kilograms. I'm going to split everything up. Let's see, meters over seconds, c, like so. But if I wanted force, I would need meters per second squared. So in order to get that, I could multiply by s in the numerator so that I get s squared in the denominator. Oops. Alright. So if you see kilograms and meters and seconds, try to see if you can get a force out of it, because that's the more universal unit element. I think this was straight from Mastering Physics, actually. This is from Pearson, straight up. Kilograms, meters per second squared. is newtons. So that's mass times acceleration. We have n times m times m times s over c times c. C to C. Okay, next up, force times distance, newtons times meters. What's force times distance? Well, force times distance is work or energy, which is joules. 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 I'll write it this way. Oh, whoops. M. Meters. Seconds. Whoops, I'm supposed to use black. Yeah, go back to black. Meters. Seconds. C times C. Ah, now we're getting somewhere. We have joules over coulombs. We also have seconds over coulombs. Okay, joules per coulomb, or energy per charge. Energy per charge. If we're talking about electricity, this would be electrical potential energy per charge, and PE over Q gives us potential V, which is volts. So we have V times M, and then here we have seconds over coulombs. Now we know what coulombs over seconds is. What is coulombs per second? Coulombs per second is an amp. If you have charge per time, it is current I. So the inverse of it would be 1 over I. Remember, these are all units here on the left side. So meaning seconds, I should say T over Q is equal to 1 over I. This means that seconds over coulombs must be 1 over amps. Inverse of amps. Very good. Chemistry, physics student. Potentially going into med school. Is that your plan, Ion? Alright. Anyway, we have volts over amps. In other words, voltage over current, and voltage over current, volts over amps, is ohms. Ohms. And we have ohm meter. Ohm meter. And ohm meter, of course, is resistivity. That was a puzzle and a half for you. And this is why I gave 23 minutes anyway, because the other questions were pretty straightforward and simple. You should have banked all your time, rushed through it. Now, of course, based on the fact that I closed the question, you can't really, go back and figure out or predict how much time you're going to need. I understand that part, but that's a deficiency of the system itself, due to obvious reasons. We want to make it the optimum testing environment, whatever that means, even though it's online. Oh, we have a new follower. Thank you for following, Cartman. Yes, make sure you hit the follow. Actually, subscribe to our YouTube channel. We're so close to 100 subscribers. Get that done. Let's go. All right. So that is all with our unit stuff. That was our quiz. Most of you did well. Pretty good. Our quiz on Wednesday will be bigger, so be prepared for Wednesday's quiz. You should now go to the site and download our tippers. Just 3 more subs. Let's go. Oh, really? We're at 97? Excuse me. That's really cool. Who's going to be the 100th subscriber on our YouTube channel? The reason why we want to get to 100 is that they will give us a custom URL we can use. So yeah, that's why. All right, so let's go and do the tippers. We'll go over tippers on Monday. Um, what else did I want to do? I didn't really want to do anything else. Projects. Oh, talking about projects. Some of our things will be canceled, unfortunately. So the roller coaster project is canceled this year. That's just because we don't have enough time. We'll still do a little bit of what is it, general relativity, talk about time traveling and whatnot and how that works after the final and AP tests. We'll still do our bottle rockets just because bottle rockets are fun. So we'll still build our bottle rockets and launch them. I am assuming we'll definitely be at school by the end of May. So the last week of May going into June, assuming school is not extended. I don't think it is because we're doing online. Um, we'll still do our bottle rocket project, which is really nice and easy to kind of send off our seniors as we launch these rockets across the girls' softball field. So unfortunately, the roller coaster project is canceled. Is canceled. What? uh, yeah. All right. Do you guys have any questions? If you have questions, ask now in chat. Ask now in chat. Otherwise, please download the tippers, work on your tippers, and work on your 3-ring binder. Get it up to date today and get it done. You have nothing else to do, right? So get that done, and then we'll move forward with our plan starting Monday. I'm gonna close this stream, but I'll stay online for Q&A. So I'll see you next time.